This is a continuation of Energy 101, and today we're going to look at energy sources, where we get the energy from that we so desperately want, that we've talked about before. And today we're going to home in on coal. We see from our pie chart from previously that 20% of our energy that we use comes from coal, 26% from natural gas, 36% from oil, nuclear 9%, and then we have some renewables, biomass and hydro being the major ones. Biomass is burning of a lot of waste coming out of the pulp and paper plants, for instance, and then you have wind and geothermal and solar. You notice solar is about 6 times less than wind. That's because of economics generally. So today we're going to talk about coal and where it comes from and how we get it and what some of the characteristics are. What is coal? Well, coal is a solid chunk, and coal, by the way, was the fuel that followed wood. Wood was the first energy that caveman used to start cooking his food with wood, and then coal came into play, and we started getting more and more of our energy from coal. Coal is an organic sedimentary rock. It forms mainly from plant debris over thousands of years, and it consists mainly of carbon. Coal doesn't have any hydrogen in it. We still include it in hydrocarbons, which indicates it's got both carbon and hydrogen. The other fossil fuels do have hydrogen in them, but coal only has carbon in it. So some people like to think that coal is being renewed and oil and gas is being renewed over time, which it is, but at a very, very, very slow rate. It's just infinitesimal how fast it's being formed compared to how fast we're using it. That's so it's definitely a finite resource from the time scale that we are using it. So that's some of the basic characteristics of coal. What do we do with it? As all the fossil fuels that we use today, we react the carbon that's in the coal with oxygen that's in the air, and that forms CO2, and the chemical energy on the right-hand side of the equation is less than the chemical energy of the 2 independent molecules on the left-hand side. That means we're releasing the chemical energy content, and it is being released as heat, or comes off as a flame, and of course the flame is hot and we get heat from it. We can heat our homes with, we can make steam, we can cook with it, etc., etc. So how do we get this coal? Well, there are 2 basic means by which we get coal. One is open mines, in which we just go from the top of the earth and dig down in an open pit and mine it out of the open mine, and then there are underground mines. We started primarily with underground mines, and coal miners worked underground for long hours, and in order to extract coal from the underground mines. This is just a shot of one of the shafts going down into a coal mine. There are many coal miners that, particularly in the winter months in the northern hemisphere, never see the light of day when they're during the days they're working. They go down into the mines before sun comes up, and they come back up after the sun has set. So it's a difficult working environment. It's methane will generally be released as you mine the coal and break the coal away from the walls, and you have to be careful of that. It can cause explosions. The dust from the coal can cause explosions, coal dust explosions, and you breathe the coal dust is not good for your lungs. So it's a difficult working environment. They've gone recently a lot to open pit mining. Here's an open pit that's shown from just dug down, and you have the roads that wind down into the bottom of the mine, and they clear off the dirt from the top of the coal and then go down and dig the coal out with big shovels such as this, and load it on the mining trucks and haul it back up out of the mine to the surface, and then put it on trains and carry it away. This is another shot of a open pit coal mine on the left that has been closed and has been restored. Of course, the dirt and hasn't been put back on. It's just been pushed off into the valleys, but grass, as you can see, have been planted there. And along the right-hand side, we have some active open pit coal mines. And you get residue ponds where you get water that comes out that's got arsenics and mercury poisons in them. So it's coal is a difficult fuel from an environmental impact on getting it out of the ground, no matter which way we go, whether it's underground in through underground mines, or an open pit mining. It comes out of the mines or the open pits and is put on trains. Train companies, railroad companies, rely substantially on the base business of just hauling coal from the mines to the power plants. Electric power plants is where most of the coal is being used. We'll see in just a minute. And during the summer months in particular, when the coal power plant is running wide open, which is not unusual since they're the last power plant to generally be shut down when the demand decreases, they're using about 100 train load cars of coal a day. So you have to bring in 100 coal cars such as these every day to keep the power plant supplied with the fuel. So it's a massive operation. That's just for one coal power plant, electric power plant. But it's a major industry, both on the mining side, the transport side, and of course the power plant side. We'll look at some of the emissions characteristics of the different fuels. We'll hold that to talk about the environmental impacts in general separately. But coal is actually one of the few, and basically the only one of any significant numbers that we export. We actually export about 8% of the coal that we mine. And all of the coal that we consume is produced in the U.S. here domestically, and we actually mine about 8% more that is shipped out to other countries for their use. So we are totally independent of other nations regarding coal, unlike oil, which we'll see later on. How do we use the coal? As I mentioned, most of it's used for electric power plants. About 93% is used for going to these power plants where they can use 100 train loads of coal a day. Industry, for various chemical reasons in general, use about 6.5%, and commercial buildings, actually some of them are still heated by coal, very few percentage. It's such a handling problem to get the coal into the basement of the building and put it into a furnace and create the steam that goes around the building to heat it. But those are the primary utilization in use that you have, where the coal goes. One thing I wanted to mention that I didn't say earlier, and that is that there's a different environmental impact other than the air emissions that come off of burning the coal. Once the coal is burned, you have ash, coal ash, that's got arsenics and mercury in it and poisons, and they're solid particles from that don't burn, and they have to get rid of them from the boiler and the firebox, and they put them in ponds. And these are toxic ash ponds, coal ash ponds, and every once in a while one will rupture and the pond will break, the dam will break that holds it in, And this happened about 5 years ago with TVA. And this is a picture of where a house was almost covered up by this ash pond spill. It's a terrible toxic situation. It polluted the river that it ultimately ran into. It's just one more aspect of coal that we have to worry about and deal with. Thank you. We'll talk about natural gas next time.